That great builder stood over there. And I say share screen, and Zoom says, "Oh well, you have to have permission to do that." So I'm like, "Okay, here's permission," and it says you have to reboot. Right? Security is so inconvenient, right? Yeah. Okay, we'll stay that way. Yeah. So this talk is called Security for Wi-Fi Wizards. We'd all like to be Wi-Fi wizards. I do the Wi-Fi wizard thing because my dad, his actual name was Merlin, like the Welsh wizard. So I really am the descendant of Merlin. Right? Sounds fantastic. I'm Phil Morgan. I am the EIO. So many people say that they're the CTO or the CFO. I decided I want to call myself the EIO. Fans of Old MacDonald may recognize that. We have to do this the hard way. Okay. This is a little bit about my company. I work for a company called NC Expert. We do development, training, lots of things. I'm not going to bore you with this. You can watch the video or look at the slides or whatever. This is me. I've been doing wireless for the longest time, blah, 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 blah. This is how you contact me if anybody does want to reach out to me. I actually would like you to do that. We do a lot of development for a lot of companies. We are currently developing a project on threat hunting for a large company that I'm not allowed to name. If anybody knows threat hunting a lot or really well, I'd love to hear from you, please. So reach out to me. Here's the information. I'll present this at the end, and you can take a screenshot, whatever. But if you are really good at threat hunting, please let me know. Okay, let's do this. I do have to say that what I'm going to talk about is real. We have to do this for legal consequences. What I tell you, if you use it to break into the Pentagon, it's your fault, not mine, right? I'm not going to actually give you that much information so you can do that, but it's a simple step from what I'm going to tell you into actually doing this. Let's talk with the basics. So I firmly believe that inconvenience is a hacker's best friend. And whenever I say it's very inconvenient, I want you all to shout out, inconvenience is a hacker's best friend. Let's make this participation. I firmly believe we are not paranoid enough. Really, really, we need to be more paranoid. I firmly believe that you can't fix stupid, just like Mrs. Gump said. We can help it a little bit. And longer passwords are generally better than complex passwords. Okay. Let's talk about the CIA, not that one, the other one. Everybody knows about the pillars. You all, I'm assuming, have the basics understanding that we talk about confidentiality, integrity, and availability. We also care about non-repudiation and authentication. Okay, very important. Yeah, we know that. Okay. Are they all important? Well, you decide. Do you need all three, or are you happy to go with just two of them? Your call, right? Okay. Sometimes integrity, authenticity, availability are good enough, but you also need confidentiality. Your call. Okay. What do I mean? You're not paranoid enough. It's really simple. We're not paranoid enough. What I wanted to do was I wanted to present a QR code. And I wanted to let you click the QR code, but I was told by legal that I couldn't possibly do that. So what I'm going to do instead is warn you not to click this QR code, okay? Then I'm going to do something, and I'm going to click the QR code. Ready? Okay, don't you click it, it's at your choice. Ready? Right. When Jackie showed us a QR code, when Jackie showed, that wasn't supposed to happen. Yes. Uh-oh. It's a wonderful world, it really is. When Jackie shows us a QR code, you're perfectly safe, right? When you start in a restaurant and the menu is selectable by the QR code, you possibly aren't. Be careful what QR codes you link to. We need to be a little bit more paranoid. Did anybody click? Hopefully not. I did, you saw what happened. And that's all that does, by the way. It takes you to a tiny URL link that links you to a YouTube video. So first of all, I want to talk about wireless. Wireless is as safe as Ethernet. Okay. Some would argue it's safer. You sure, Phil? Well, let me emphasize something that you may have missed. Wireless, when configured correctly, is as safe as Ethernet. And that is a big win, okay? I guarantee you that wireless isn't going to be encrypted, okay, in many, many cases. Problem with Wi-Fi, I'm talking about Wi-Fi wireless particularly, what we use to connect at the coffee shop, at home, at the airport, on the plane, and here. How many of you are connected via Ethernet today? I rest my case. You're all connected via Wi-Fi, right? Excellent. And that proves that there's always an exception to the rule. Thank you. The issue with wireless is you broadcast it. Not broadcast like in Ethernet, where you send a broadcast frame. It is broadcast from a device out. And anybody that has a receiver can hear it. That is the point. It is a broadcast medium. Okay? I want to clarify something that a lot of people really don't understand. They understand that if you turn up the volume on the speaker, more people can hear the volume. What they don't understand is you can also turn the volume up on the listener, okay? Boundary of a network, being too far away, is never a security mechanism, right? Just because you cannot hear the signal outside of a predetermined area, doesn't mean that I can't hear the signal outside the same area. If I use a different antenna combination, I can hear your signal more loudly. I can break into your Wi-Fi network from half a mile away. You don't know where I am, you don't know I'm doing it, but I just need line of sight and hopefully not a building in the way. Okay. So if you're being hacked and there's a gripping open space outside your building, try looking in that direction. Okay. Because if I'm going to attack you, if one is going to be attacked, I should say probably, Wi-Fi is the easiest way to do it. Absolute easiest way to do it. There are real monsters out there in the world, and we can protect ourselves from them. Okay. Werner Vogel says, dance like nobody's watching, but encrypt like everybody is. And I think I'm preaching to the choir here. I think everybody knows we need to encrypt our data. We've heard it multiple times this morning. So a couple of things to understand about Wi-Fi. And Phil, you're talking about enterprise Wi-Fi, right? What we do in the business, not home Wi-Fi. It's exactly the same thing, no difference whatsoever. There are two ways to use wireless Wi-Fi, and only two ways: without security and with security. The end. What do you mean without security? At Starbucks, I should mention names, at coffee shops, at airports, on airplanes, anywhere where you don't have to do anything else other than just connect, then that's a network that has no security set on it. Okay? It's not a bad idea because it's the way we use guest networks. But we maybe want to reconsider. You probably use captive portals. How many people here work in a company that has a guest network? An actual guest network with people that connect. Okay. How many people here have a guest network with a captive portal? How many people hate captive portals? Right? Yes, the same people that put their hands up for how many people have a captive portal, put their hands up for. And those people who didn't put their hand up because they hate captive portals, use captive portals, not support them as an IT administrator, right? Okay. It's not a problem with the captive portals, it's a problem with our Apples and our Androids and everything else. They want to serve us and they want to eagerly connect to us. And they always try and connect us quickly. And they try and detect that it's a captive portal, and they do stuff that messes up captive portals. So at the moment, captive portal is still the way you secure a network that's open. And basically, to explain what is a captive portal, you go to the coffee shop, you connect, you open, your email doesn't work, nothing works, you open a web browser to try and get some help, and it says, oh, hello, welcome to the coffee shop network. Do you promise to do the following things? Be nice, be kind, not download nasty stuff or illegal copies of Spider-Man 3. Yes, you click yes, and now you're allowed to connect, right? That's a captive portal. So let's talk about some basics. These are people who you need to understand and know about in the wireless world, in the Wi-Fi world. The FCC are in charge of power levels and frequencies and what channels you use. The IEEE are most famous for creating the standard and amendments. The real people who do the real work you care about is the Wi-Fi Alliance. They're a vendor group that creates certifications. So if you want to buy a device that does something, you want to buy it with the WFA, the Wi-Fi Alliance certifications, okay? The real power is the IEEE. Phil, what are you talking about? The IEEE rule everything? No. How many of you use the 802.11i protocol? Anybody use the 802.11i protocol? You're all using it right now, okay? Only it's not called 802.11i. It was rebadged by the Wi-Fi Alliance. It's WPA2. How do I know you're using WPA2? Who connected to the Pacific Hackers SSID and typed in a passphrase? WPA2, right? 802.11i, exactly the same. The IETF creates some stuff that we use and reuse, so we don't want to reinvent the wheel. So the radius protocol, the Kappa protocol, the EAT protocol are used by those guys and gals. So as I mentioned, there's two ways to use Wi-Fi: with security and without security. There are two ways to use Wi-Fi security according to the WPA2 standard, okay, or certification, I should call it. Standard in the sense that it's a standardized thing that we use. It's not a legitimate standard, it is a certification, but only people like me who work in the industry really care about that. There's personal and there's enterprise. Personal, you type in a PreShared key. Enterprise, you connect to some sort of complex radius server and you type in a username and a password, you download a certificate and all sorts of other things. So here we see we have without security. You can see my mouse moving. And on the right, on the left, we have with security. So there's only two options: personal with a PreShared key, which is what we all did today, and enterprise, which is probably what you do in the office. How many of you go in the office? Your machine had to be onboarded by a team. You turn it on, something magical happens, it pops up and says, what's your username and password? You type in your username and password, and it says yes, and everybody's happy, right? That is a much more complex way of using Wi-Fi. How many of you use enterprise-grade Wi-Fi at home? And you can see the smile on my face. You do. See it. There's always an exception. That man is probably the smartest man in the room, okay? Because you aren't, well, it's difficult to break into his network than other people's networks. But of course, you have to have a radius server or some kind of radius service, which you aren't going to install at grandma's house, right? Or you are, but how's she going to maintain it? Please understand that only the people on the left-hand side, only people on the left have any sort of security. Or the people on the right send in data in plain text over the internet. Okay, so if you're at a coffee shop, I can read all your emails, I can see all your passwords and everything. Unless, of course, you're using SSH, because you probably are smart enough to not use Telnet from the office, from the coffee shop. You're using some kind of SMTP with a TLS link. You're using POP3 or not the other one, POP3 or some kind of way to read your emails. Or no, Phil, I'm using a VPN, thank you very much, right? Again, that's the way we need to do it. When you're using anything that does not do the four-way handshake, you have no security at all, other than security that you use by using a VPN or using HTTPS, not HTTP and stuff. If you make a voice call and it's not encrypted, secure voice, and this is stuff that I show people in classes and in demonstrations, we make a voice call and then I replay the voice call. Because if it's not sent encrypted, it's sent open. And if you're on a voice call from your device at a coffee shop, if you're using Skype or WhatsApp or any of those, they're going to be encrypted today. Okay? If they're not, anybody can hear it. So if you're using PreShared Key, WPA2 personal, you take the passphrase. May the force be with you. That passphrase is mixed 4,096 times. This little device is right over the top of the most interesting thing. No, like what I said, it doesn't say 4,096 times. Oh, I apologize, it's there. It mixes it 4,096 times with the SSID to sort the passphrase and give you what is known as the PreShared key. That is the PreShared key that is used in the protocol to let you onto the network. Okay. WPA2 personal, known as PreShared key. You have a common password entered manually or calculated from a passphrase. Everybody who knows the passphrase can access the network and de-encrypt the traffic. So I can capture all the traffic that you were sending over the wireless network very easily, and I know the password, right? So I can de-encrypt all your traffic, and you can de-encrypt each other's traffic, and you can de-encrypt my traffic, which is probably a good idea why you should all be running a VPN or HTTPS or not Telnet. You all with me? You understand? We need to be more paranoid. This is now, PreShared keys are perfectly safe. Pause, comma. As long as you change the password every 30 days. Specific hackers doesn't have to do that because it's on the wall. Okay. If they want to change it, they just reprint it on the wall. Okay. Hacker Dojo doesn't have to do that. They can change it whenever. The problem with PreShared Key is if you use it in the office and you don't change the password ever, when somebody leaves the company, they know the passphrase, which means they can capture your data and connect to your network. And you decide which one is more scary. You have to use a serious level of complexity. I believe they're saying that today you should be using 18, 19, 20 character passwords. It's the first thing you're going to do when you use a 20 character password. You're going to write it down. There's the problem. If you use a passphrase, use a 26 character password. May the force be with you. Space, Phil Morgan, @ampersand. Okay, that's very easy to remember. I'm going to ask you what the password was at the end. You should all be able to remember. Let the force be with you. Space, Phil Morgan, @ampersand. Very easy to remember. You don't have to write it down. Okay. The problem is all of these things are very inconvenient. Inconvenience is a hacker's best friend. Okay. So the four-way handshake is very convoluted and complex. I can give you the short version because you don't want to sit there for 20 minutes while I explain it. You take the passphrase and you mix it up with the SSID, and that becomes the PreShared key. This is a 64-byte value. That's the PreShared key. Cut in half, and that becomes known as something called the PMK, the pairwise master key. Very important. If you use the WPA2 enterprise version, as a result of a successful authenticated connection, you get a master session key. The master session key is again manipulated into the same size of a PMK. It's 256-bit key. The PMK is then shared. It is shared or known or calculated on the client, called the supplicant on the left, and on the infrastructure, the access point on the right. They then exchange some data, the four-way handshake. There are 4 steps to the four-way handshake. They're really clever, these security people. They know how to name it, right? The four-way handshake. The access point includes a random number, nods. The client now knows the PMK. It knows its own random number. It knows the access point's random number. It knows the supplicant's MAC address. It knows the access points, the authenticator's MAC address. Mixes them all together and creates the pairwise transient key. That's a big key that is split up to make other keys. It then sends its random number with a little bit of basically a fancy cyclic redundancy check calculation back up to the access point. The access point has what it needs. It now creates hopefully the same pairwise transient key. The TK is the temporal key that's used to encrypt all the data. The other keys are used for other things. You don't need to worry about them for that. The broadcast key is encrypted in the third key. Hold on a second. We have a unicast key for unicast data. What if I want to send a broadcast frame or a multicast frame? So there's a second key that has to be generated and shared. That's the broadcast key. That is shared in exchange number 3. And in exchange number 4, we get the thumbs up, we're good, everybody's happy. That's the four-way handshake, nice and simple. Now, key point. If you use WPA2 personal PreShared key, everyone, every time they connect, are using the same PSK and therefore have the same PMK. Everyone, every time they connect. If I break your passphrase, I know your PMK, I own your network. Now, in the past, and forever. If I capture data you transmit today, I can go away and I can break your PreShared key, and I can break the data I captured today in a year's time, in 10 years' time, in 20 years' time. Okay, so if you were doing anything important and you're using PreShared key, you probably shouldn't be. Short passphrases are very, very easy to crack. Talk to the guys who sat in the wireless class yesterday. They're nodding. We broke wireless passwords yesterday. No, they were simple passwords. They were designed to be easily broken. They are very easily broken. Anybody know what a Tamagotchi is? Anybody have one? Yeah. Anybody have more than one? I have 4. Yeah. It's a little Raspberry Pi 0. You feed it PreShared key four-way handshake exchanges. It's like the game from the 90s. There's a bit of information there for you. What it does, it captures WPA2 handshakes, captures PMK IDs, stores them as a PCAP, If it's bored, if it gets lonely and bored, it starts de-authenticating people to make them reconnect. Because when they reconnect, the first thing they do is they do the FourWay handshake. Okay, it uses artificial intelligence to learn how to get better. Well, artificial intelligence / machine learning. We have another conversation about which it is. I'm going to mention in a minute. Can it travel back in time to kill you? No, then it's machine learning, right? It's not artificial intelligence. Watch out if you do use this. It sounds like a fun little toy, but maybe you shouldn't take it to the airport. You shouldn't take it to the police station. You shouldn't take it into a military base and so on and so forth, because it will start doing de-authentication attacks and start capturing keys, right? You can put it in polite mode where it just simply collects. And collecting anything that is broadcast, I don't know if anyone understands the law or is a lawyer or anything, but if you broadcast something openly into the air and I capture it, I'm not entirely convinced I've done anything illegal, okay? Because you broadcast it. So if you take this onto one of these sites, they probably will make a fuss if they catch you. If it's just capturing stuff, no big deal. But you don't want it de-authenticating and disconnecting people on like a military base in a government building or something. Like don't even take them to DMV, right? Don't do that. Anything you want to know, you can go there. Did a talk on it back in Pacific Hackers. It's on the video on the YouTube. There's a link to it. It was a long talk, we went on a bit, lots of questions. But it's how to build one from scratch. And it's a great little toy to play with if you want to learn about, or if you want to be able to capture FourWay handshakes easily. But there are alternatives to giving everybody the PreShared key. I call this IT PreShared key. It's a name I made up. Only the IT team has the PreShared key. And when you want to connect, you take your device to the IT department and they type in the PreShared key for you. You don't need to change the PreShared key as often. You don't need to change the password when someone leaves the company, but you do need to decommission the device to take the key off it. Still must be a serious level of length and complexity. All devices need to be taken to IT for onboarding and decommissioning. These are all very inconvenient. Inconvenience is a best friend. Fine. It's another way of doing this that vendors have caught on to now, and there's different vendors have different names for it. PPSK or IPSK or MPSK. Basically, it's personal PreShared keys. So a PreShared key is just a passphrase, just a password. You don't have to have one of them. So you give everybody their own PreShared. And this is genius because you don't have to change PreShared keys so often now. You can overlap PreShared keys. Just say, hey, Phil, use this one whenever you're ready. This one's going to retire in a month. You don't need to decommission devices. When someone leaves the company, you just delete their PreShared key, right? It does, of course, lead to someone's going to manage this. There's an extra level of management. You still should use a serious level of length and complexity. Maintenance, as I mentioned, could require some overhead. Doesn't completely work with the latest technologies, WPA3 today. So it's not the perfect solution just yet, but it's a short-term solution for WPA2. It's also a great solution for guest networks. When someone arrives, you can just create a random password for them or password 73 or whatever, and give it to them on a little sticky label, print it out, give them a little sticky label, and they can take it with them. So it's a great alternative for guest networks, because now the guest network is using the PreShared key concept, which means you do have encryption. So no one's walking around your network inside your building quite open, because the problem you've got now is what if other people capture them on your network? It's a whole other legal issue that somebody else can deal with. When you move on to WPA2 Enterprise, it uses the editor, I call it editor 1x EAP radius. It's based on the editor 1x principle, using the EAP protocol and using the radius server. Okay, so a supplicant on the client on the left talks to an authenticator, which is the wireless infrastructure, the wireless LAN controller, if you're Cisco or Aruba, the cloud if you're Meraki, Mist or Extreme, and so on, and the access points. On the back end is a radius server that is the interface that stores the usernames and passwords. We don't use radius to store the username and passwords today. We most likely interface that over to an LDAP, Microsoft Active Directory or something. Does anybody know what radius stands for?
We know as
Dial in, user service, right? You mean modems? Yeah, it was invented for the use of modems. Okay, but technically you're dialing in when you connect to the Wi-Fi. So why reinvent the protocol? It's the same concept. So today we use the radius concept to authenticate, but instead of storing usernames on the Radius server, we actually use the interface. Usually Microsoft Active Directory is like the largest, most widely used form of LDAP in the world. So enterprise requires the use of EAP and Radius. We'll need to use certificates or the Cisco variation of something called EAP Plus. Devices will need to be onboarded. You have to onboard the certificate. You have to install a certificate somehow by group policy or manually to allow them to authenticate the certificate that is given to you by the Radius server. This can be very inconvenient. Oh, here we go again. Inconvenience is a hacker's best friend. Arguably the safest mode of Wi-Fi security today. Pause. When configured correctly. How many of you use WPA2 Enterprise in the office? How many of you didn't put your hand up because you're smart enough to not tell me what security you use in Wi-Fi on the office? Right, yeah. Remember, we aren't paranoid enough. Okay. Don't worry about it. It's very easy. If I stand outside your office, I listen to your broadcasts from your access points on beacons, I know exactly what security you're using because you advertise it to me 10 times a second, so I know how to connect to you. I have, but we don't turn on broadcasts, Phil. Yeah, that means you don't advertise the name of your SSID. You still advertise it. People who sat in the hacking class yesterday, did we do anything about that? Yes, we did. We just waited till somebody comes along. So hiding broadcast doesn't mean you don't beacon. It means you don't advertise the SSID name. Now, any hackers going by are like, why are these people hiding? Why are they not advertising the SSID name? What are they hiding then? So you've now piqued their interest, right? And all they're going to do is sit there and wait long enough because the beacon's been, I'm not telling you who I am, but there's a network here. I'm not telling you who I am, but there's a network here. I'm not telling you who I am, but there's a network here. And then Joe turns up for work on Monday morning and says, are you there, secret network? And the access point says, yes, I'm here. Welcome to secret network. Come on into secret. It just give away your SSID there. Right? And we did this yesterday in the hacking class. It's real easy to do. You don't have to do anything with it. You just load, if anyone wants to know, you load AirTrack NG, AirMon, and you put the interface in monitor mode and just run arrow down. And it'll sit there and it'll say hidden network. And then it'll say, oh, not a hidden network anymore, because it literally looks for beacons and tells you what they are. Sorry, it looks for probe responsive and probe requests and tells you what the hidden network is. Problems with enterprise. This is quite possibly the dumbest thing ever invented, and it's up there with a lot of dumb things. When users are presented with a certificate that's invalid, they have the option to say, continue anyway, which is quite possibly really, really not smart, okay? Don't allow it. You can configure group policies in Microsoft. I'm not a Microsoft person, I have an Apple. Okay? I know a little bit about Microsoft, but I'm not a huge Microsoft admin person. You can do MDM control with like Meraki or Jamf on Apple. And you can say that people aren't allowed, they aren't allowed to not use this certificate. This is the only certificate that is allowed to connect them to secret network. Any other certificates are not allowed. That's probably like a really good idea, but does anybody know if they do this? Some of you maybe don't know. Some of you maybe are not going to put your hand up because you're like, oh, we need to start doing that. Sure, it's fine. All of this, here we go again, can be really inconvenient. So I told you about the FourWay Handshake. Okay, it's the same FourWay Handshake that is used for WPA2 Enterprise that is used for WPA2 Personal, PreShared Key. Key point to understand, if you use WPA2 Enterprise, everyone, every time you connect, has a unique MSK, and therefore you have a unique PMK, okay? So all the Wi-Fi attacks we did in the class yesterday, and most Wi-Fi attacks that are done against you are done against the PreShared Key. It's much more difficult to do attacks against, not impossible, against WPA2 Enterprise. Okay? You can do attacks against WPA2 Enterprise, but nobody in their right mind is going to attack the PTK. That's going to take a lot of processing power and break the passphrase or the PTK you got when you signed in at 9 o'clock. When you logged out at 10 o'clock to go for a coffee break or to go to the meeting, when you come back at 10:30, that's a different PTK. You all see that? So hackers aren't going to bother to attack that. They attack other aspects. All right. So WPA3, magical unicorns and stuff. It's going to save the world. Can we have a cheer for WPA3? 1, 2, 3. Hurrah! Thank you. Thank you for playing. Right. We have 802.11ax. How many of you have AX devices? How many of you have a laptop or an iPhone that you bought in the last year? How many of you, and this is a very interesting point, how many of you have a Samsung that you bought in the last 2 years? Interesting point. It's an 802.11ax capable device. Okay? Trust me. The other thing, and it's coming, it's here now, this ship has sailed. The other thing that's coming is 6 gigahertz. Anybody have a 6 gigahertz device? Anybody? Oh, nice. Yeah. I think I brought my Samsung, so I'll play with that. Yeah. I have an Apple. I love Apple. How do you know when you meet an Apple fanboy? Because he'll tell you within 10 minutes, right? Okay. I love my Apple. If Apple's listening, please give us some more 6 gigahertz stuff, please. My Samsung S21 has done 6 gigahertz for 2 years. Okay. My iPhone, I thought, oh, this year, this October, this is when I buy. No, the iPhone doesn't do 6 gigahertz. We now have an iPad with 6 gigahertz, so we're getting there slowly. 6 gigahertz, it's not going to happen tomorrow. It's going to take time. How many of you have a laptop that's a year and a half old and don't get a new laptop for another year and a half, maybe? So you've got to wait a year and a half before you get a new laptop. It'll probably be a 6 gigahertz laptop when you get there. I have a Dell. If anyone wants to come talk to me, come and talk to me. I'll show the model of Dell that I bought. You take the back off, you plug in an Intel chip, and now it does 6 gigahertz. It's not a 6 gigahertz antenna. It's not the best 6 gigahertz, but it's 6 gigahertz, right? I have a Samsung that does 6 gigahertz. We get in there. And now we have 6 gigahertz on the ceiling at the dojo. Fantastic. This is going to happen. There's a lot of debate going on. I jokingly said at a conference I was at 4 years ago, let's skip 6 gigahertz and let's go to Wi-Fi 7. And everybody groaned. And somebody's actually suggesting that in the industry. Broadcom and Intel are going to have Wi-Fi 7 chips out next January, I believe. And so people are really, don't even go there, people. Come and talk to me if you want afterwards. Go for 6 gigahertz now. 6 gigahertz is going to become ubiquitous in about 2 or 3 years. Wi-Fi 7. So let me clarify. 6 gigahertz is Wi-Fi 6E. Okay. AX is Wi-Fi 6. AX in 6 gigahertz is Wi-Fi 6E. Wi-Fi 7 is really 3 years away from being standardized and probably 6 years away from becoming ubiquitous. Just a long way off. Anyway, back to WPA3. WPA3 is the next generation Wi-Fi security. It really is rainbows and unicorns. It simplifies, enhances security, robust authentication, increased cryptographic strength. It stops us using protocols we shouldn't be using anymore, like TKIP. Okay? It requires something called PMF. I don't know if you know this, but all of you in the room, unless you're using WPA3, which I don't doubt if anyone is, I can disconnect you from the network real easy. Okay? I say to you, hey, insert your name here. Please disconnect. This is your access point speaking. Please disconnect now. And you all go, okay, because that's the way Wi-Fi works. Right? Protected management frames are where we have a negotiated. You remember, if you look, let's look back a little bit, just really quickly. These little spare on the right-hand side, to the right of TK, there's little spare keys that aren't being used. Well, we have a use for them then. They are used to create keys. They will be used to create special MIC values. Whenever someone says MIC or MAC, not as a MAC address, but as a MAC authentication code. Whenever they use MIC in that context, it's a fancy CRC, it's a really glorified cyclic redundancy check. What happens is, when I send the message saying, hey, insert your name here, disconnect, here's our secret password. If I don't use the secret password, or I use the wrong secret password, you go, no, I'm not going to disconnect. It's that simple. Okay? PMF is required in WPA3. So how many of you have ever hacked into Wi-Fi? How many of you have ever hacked into Wi-Fi but don't admit it? How many of you have done a de-authentication attack on Wi-Fi? Okay, nobody, sure, I believe that. I know that 3 of you in the room did it yesterday with me, so right. The point is, you can't do that anymore. Anybody ever had a problem in work where they keep on getting de-authenticated by somebody else? Because Meraki and Mist will do this. If they detect what's called a rogue AP, they will de-authenticate you. But the problem is, it's kind of illegal to do that if it's a legitimate AP. If you're using the name of their SSID, it's open season. But PMF just stops that. Protection of management frames. The problem with WPA3 is there's a transition mode, because we always have to be nice to those people who haven't caught up yet. It's not fair to limit to only connect to WPA3. So we're going to allow people, if they don't support WPA3, to say they don't support WPA3, then we will use WPA2. Anybody see any problems with that? Any issues? I turned on WPA3, and the hacker just simply comes along and says, oh, I don't support WPA3. And the infrastructure says, well, let's turn off all this fancy stuff then, and let's use WPA2 then, right? Oops. It's going to have more protection for users, easier, secure onboarding, higher level protection on open networks. So that's really cool. We'll talk about in a minute. And optional 192-bit security for those people who are really paranoid, like the military and the government and so on. Things you didn't know about WPA3, you didn't know about Diffie-Hellman, ECDH, SAE, and OWE. OWE isn't actually a part of WPA3, but it's coming along with it. What WPA3 does, it separates the creation of what we talked about as the PMK. Do you remember PMK? That is now separate from the PreShared Key. This one step makes WPA3 infinitely more secure. As of July 2020, WPA3 personal is required for Wi-Fi 6 operation. WPA3 Enterprise and OWE, it's optional. That's going to change in a minute. So, quick summary for all those who need a coffee break. WPA3 fixes the problems with WPA2, and it's super duper mega awesome. Okay. It started with something called crack. That was an easy way to attack Wi-Fi networks. Okay. Invented by Matthew Van Hoff and Imek Distrinet. It was a way to force the access point to reuse a previously used random number, which might not seem like a big deal, but when you have an infinite possibilities and you reduce them to a small number of possibilities and you have a lot of processing power, it's a huge deal. So what's wrong with WPA2? So up in the top right-hand corner there, let me just point something out. I'm here talking to specific hackers. So I'm not a crypto billionaire, right? Clarify that now. But I did build a crypto machine, and it made Ethereum, and it made Ethereum, still made a lot of Ethereum until a month ago. They stopped doing it that way. So now I have this machine with all these graphic cards. It costs about $2,000 to build. It's a lot of money, but I made that back. Asked my wife, did you mind him doing this? She's like, well, it's cheaper than golf. I got to see him an awful lot more, so she's happy with it. But of course, it doesn't do nothing now, does it? Well, we did a session about a month or two ago with Irvin with Hashcat. Hashcat needs a lot of processing power. Oh, can you get Hashcat to run on your old crypto mining machine, Phil? Yes, I can. It took, to give you an idea, and those who understand it will understand it, it took 3 minutes to break the WPA2 passphrase with a dictionary attack on my Kali Linux as a VM on my laptop, when the word was 700,000 words in the dictionary. It took 3.5 hours to do a dictionary attack on my Kali Linux when the word passphrase was an 8-character word that was 9 million words in the dictionary. Anybody want to guess how long it took this to brute force the password? 0.26 seconds. Now, hold on, time out, time out. It was a capital letter followed by 6 lowercase letters followed by a number. And this device broke it in 0. And it wasn't a dictionary attack, it was a brute force attack. If you have an 8-character PreShared key on your network and you think you're safe, come and talk to me later and we'll have a little chat about it, right? 0.26 seconds. Okay. I thought it was broken. I started it up. I went for a coffee. I came back. Oh, it's done it. Oh my gosh. Even I was surprised at how quick it did it. So, and of course, the point was I broke that passphrase offline. I stood outside, it was my network. I stood outside the building, captured a FourWay Handshake, went home, did this from the comfort of my home. Once I know you're PreShared king, I'm the king, right? WPA2 also lets you not use security. And of course, it uses crack. Let me just clarify. WPA2 lets you not use security. No. Think, Luke, I am your father. No, don't. Try not to do that. Okay. Sometimes you have to, I understand, but we'll see if we've got a solution coming up for that in a minute. So there must be a problem. This is 2022, we're going to go to Mars, there's all sorts of stuff. You do know that your Anybody have an iWatch or a Samsung watch or anything? You know that's got more processing power than a 1960 supercomputer. You know that, right? It's a lot of power in the watches. Your iPhone, this little Apple, it's the one with, or the M2, no, the M1 Pro Max or something. This has got more processing power, I think, than 1970s supercomputers. Okay. We have machine learning, and there's the reference I told you about, AI and machine learning, like Cyberdyne Systems. Anybody know Cyberdyne? You're Terminator, right? There is actually a company called Cyberdyne Systems. You all know that, right? Coincidence or prophecy? Your call. No, nothing we can do. We can't fix WPA2. Use stronger and longer passwords and try not to write them down. That's all, folks. That's all we got. So WPA3 was designed to fix all of this. It's resistance to offline dictionary attacks. Stronger protection against password guessing attempt. Now, if you can see it, I thought, oh, I shouldn't say stupidly easy passwords. Then I went to delete it and I thought, well, I need to mention that some people use stupidly easy passwords. So I compromised and pretended to cross it out. Okay, right? Even if users use stupidly easy passwords, 1, 2, 3, 4, 5, 6, 7, 8, they get better encryption with WPA3 personal with that password than you got ever before with WPA2. Okay, so if you have a stupid password, it means people can get on your network. They can't decrypt your data anymore. That's like a wow. Okay, it provides forward secrecy. So if I capture your data now, I can't guess your pre-shared key in 10 years' time and reverse engineer your data. I have to attack the key that was used to encrypt the data, not attack the key that was used to create the key that is used to encrypt your data. That is a big thing. And the changes are invisible to users. However, you need device support. You've got to have device support. So you can't use WPA3 on a device that doesn't support it. Now, just quick story. I turned on WPA3 on the Eero computers at my house. Okay, my son says my iPad doesn't work anymore. Now, like any self-operating IT administrator, I immediately thought there's something wrong with his iPad. Then my daughter said my iPad doesn't work anymore. And as any self-respecting IT individual, I went, oh, I made a change and now two things don't work. Do you think it was me? It usually takes two for that to happen, right? And I went, okay, so I turned off WPA3 and I said, does it work now? And they both said, yes, it works. And I said, can you please patch to the latest version of software from Apple? And they did. And I turned WPA3 back on and it worked again. They didn't even need to go and buy new iPads. They just updated. And I was quite embarrassed, and I probably shouldn't tell that story. That I say children, but they're well above teenagers. Children of a current security professional didn't update their iPads for a couple of years. Hang your head in shame, right? But how many people here have kids? How many people here? How many people here? Keep your hand up if your kids listen to you. But yeah, there we go. So this is invisible to users, but you have to upgrade the devices to support it. And usually it's a software upgrade. It's not always a hardware upgrade. Let me check everything time. You know? Oh, okay, we're getting there. So WPA3 personal, the passphrase only provides authentication. SAE will replace the PreShared key for encryption. SAE will negotiate the PMK, then run the four-way handshake. SAE will exchange the SAE exchange is resilient to passive active attacks, also resilient to offline dictionary attacks. Now, if you Google SAE, you end up with that. Now, that's not the SAE. Any mechanics, you might get that joke. It's car oil. The internet, you have to search for simultaneous authentication of equals. It provides forward secrecy. It assures the PMK cannot be recovered, even if the password becomes known. Right? Update of July this year, WPA3 support is mandated for Wi-Fi 6 certification. WPA3 is the only option in Wi-Fi 6E. WPA3 support is mandated in the Wi-Fi 6 certification. So we're safe now, aren't we? Nope, you're front a minute. All right, so it's from the editor.lms mesh peering protocol based on Dragonfly, if you want to learn more about it. This is an old slide that you updated. WFA has made it a replacement for the PreShared key, but it doesn't do authentication. You are securely encrypted to the other side. You don't know who they are. It's a start. We'll work on it. You need to understand Diffie-Hellman. Quick overview. You pick color, I pick a color, we pick a common color, we mix them together. We send the mixture and the common color across the network. We each receive the other person's mix it with our color that we kept secret. So you pick a common color and a secret color. Okay. You mix them, send the mix over a public network. There is no way. It's very, very difficult for anyone intercepting the colors that you send to reverse engineer it to get back to your secret color. Okay. You might fill yellow and red, make orange. It's not hard. Yes, but you don't know the exact hue, color, saturation, blah, 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 of the color, of the gazillion colors that there can be. You don't know the exact one. Okay. Diffie-Hellman is based on finite field discrete logarithm method. Anybody understand finite field discrete logarithms? Don't be afraid. Yeah, some people do. You're the guys and gals who write the code, absolutely. 40,000 foot view. It's very difficult to reverse engineer. Creates a keyed one-way function. It's computationally expensive or infeasible to calculate the key using only the input and the output you were given, right? So it's a one-way system that's really, really difficult to reverse engineer. So you can't get this hidden color. You can't use, everybody knows you can't use the word impossible in security, right? It's impossible until someone finds a way to break it or upgrade the processing power of the supercomputer to do it. Well, you need to know one more thing. Elliptive curved Diffie-Hellmans are even better and way more super duper than Diffie-Hellman. Okay, you just need to know that elliptive curves are cool. Oversimplification. If I draw a curve, if I have a calculation, I can draw a curve. If I then choose a point on the curve, create its reflection, create a tangent, create its reflection, create a tangent, create its reflection, and I rinse and repeat. You don't know where my starting point was, and you don't know what the number of times that I iterated that. So it's even more difficult to reverse engineer elliptic curve Diffie-Hellman than it is logarithmic Diffie-Hellman. Okay. Anybody understand the elliptic curve Diffie-Hellman? Don't think I do. I just repeat what I read on the website. Yeah, some of you do. Good. So remember the four-way handshake. Okay, the output of the four-way handshake is the input of the four-way handshake is the PMK, and that is gotten from the MSK or the pre-shared key. Well, what we do is we do a special exchange at the start of WPA3, and we create a PMK using an elliptic curve Diffie-Hellman. So we no longer have any relationship with the pre-shared key with the PMK. So if I calculate or I guess your pre-shared key, all I can now do is connect to your network. I can no longer decrypt your data. Hurrah. Okay. We still do the four-way handshake at the end, exact same four-way handshake, but the PMK that we input is calculated from the Diffie-Hellman exchange, not from the pre-shared key. Now, every time they connect, have a unique PMK. Correct. WPA3 also updates WPA2. I think it introduces management frames, which and these stop DOF and de-associate attacks in their tracks. If you ever want to sit on a hacking class for Wi-Fi, go do it quick because they're not going to be able to do this so much longer. It's invisible to users, but you need device support. There's an optional 192-bit cryptographic strength for those who really are paranoid, government, military, financial, so on and so forth. And you cannot turn off PMF, which is like, thank goodness for that, right? Typically, we create something and we let people turn it off, which is a stupid idea. You cannot disable PMF in WPA3, in enterprise or in personal. Other things that come out, something called Wi-Fi enhanced open, which is just super duper. Remember we talked about you connect the network, there are two ways. Well, now there's a third way. Look in the middle, OWE in the middle here. You can see my mouse moving. OWE in the middle, it's an open network, but it runs the four-way handshake. So you have encryption, unique encryption for your connection, that no one can reverse engineer. So now you can go to Starbucks, coffee shops, this part of the session sponsored by Starbucks. Yeah. You can go to your coffee shop, your airport, wherever. You can connect to an open network and have encrypted data. No authentication, right? You don't know it's the coffee shop you're connected to, but you have a secure and encrypted, unbreakable, difficult to break link with that access point to encrypt your data. I know better than to say unbreakable because someone will prove me wrong very soon. So now there's with security and without security but still pretty good. Okay, it's kind of a halfway house. So the OWE process, you do a normal authentication as in wireless, you connect. When you do the association phase, it is a special, oh look, it's our old friend, Elliptive curved Diffie-Hellman, okay? And it does Elliptive curved Diffie-Hellman exchange in the OWE exchange to give you encrypted keys. Okay. So now everyone, every time they connect to an open network, has a unique PMK, even if they aren't connected. So even if they are connected to an open network, and even if they didn't want one, you get one, as long as devices support it. Okay, that's the caveat with all of this new stuff. Devices have to support it. It's coming. Eero. At home I run Eero, WPA3. Yes, fantastic. All right. So today our options are open networks, web, WPA, WPA2 personal, WPA2 enterprise, WPA3 personal, WPA3 enterprise. We haven't put open networks to OWEN. Okay. So my network's safe now, right? Well, if you have an open network, you've got the door open. If you're using web, you shouldn't. Okay. You know you can break WPA2 and WPA2 personal. Well, what about the last three? Well, you can break them as well. Right? I've broken WPA2 enterprise when it wasn't configured correctly. I've broken WPA3 personal when it wasn't configured correctly. I've broken WPA3 personal when it was configured in transition mode. So probably don't run it in transition mode. I couldn't break WPA3, but I broke WPA2 for a customer and then showed them it was a stupid idea to use the same passphrase on WPA3. Whoopsie, right? WPA3, this is theoretical. Never done it, never seen it, heard about it. If you don't configure WPA3 enterprise, can be broken, okay? It's much more difficult if you use the 192-bit one, because that will not let you use anything but ETLS certificates, and it's very difficult to break. Top tips, use the webs, know your environment, know what is normal, know what is abnormal. Use some kind of DNS security. One of the first things malware usually does when it gets on your system is reaches out to a command and control server. We saw this morning, people demonstrated this. Well, if your DNS system says, you know what, I'm not letting you connect into nastyvirusplace.ru. No, I'm not letting you do that. That's a huge bonus, okay? This will interface with like Meraki, for example. And use PMF, turn on protected management frames, which means you have to use the new protocols, which means you need support for the new protocols. So key takeaways, use WPA3, do not use transition mode. If you do use transition mode, everything becomes WPA2. Use a different SSID for each frequency. Use a different SSID for WPA2 and WPA3 clients. Don't use the same PreShared key on WPA2 and WPA3 SSIDs. But Phil, last time, these are so inconvenient. Last couple of things, couple of comments. Clean up your cache. If I come and sit outside your home tomorrow, it's 100 miles away, you will still advertise for Pacific Hackers because you're connected to it. So I'll set up my AP to be Pacific Hackers. You gladly connect through it. I'll give you internet connectivity, and now I'm capturing all the data on the wired side, not the wireless side, right? I can find you from your probes. Okay? Be paranoid. Be careful what you plug into. Don't go to airports and plug your phone into a USB charger at an airport. Plug your phone into a USB power bank and then plug that into your phone. Okay. To learn more, you can look at this on the website. I'm aware of time. We do a class on this. If anyone's interested, reach out to me. A 3-day introduction class and a 2-day advanced. And I think I'm done. And I did a more deeper talk on this, Pacific Hackers, about 6 months ago, I think it was. It's up there on the website. Thank you very much. Thank you.